Okay, we're going to review the algebraic representations of translations, reflections, and rotations. Because like we talked about, in 7th grade you had to translate and reflect different figures on a coordinate plane, but this year you have to be able to write out in algebra what you're doing with each one. So we're going to start with a quick refresher on translation. So that's your first section. And we need to fill in our key. So our key has the different keywords that you would see for where the figure is going. So it can either go right, left, up, or down. Now if I picture a coordinate plane, here are my positive numbers, my negative numbers, my positive numbers, my negative numbers. If I'm going to the right, that's this direction. I'm on the x-axis, and I'm going in the positive direction. If I'm going to the left, I'm on the x-axis also, but I'm going in the negative direction. Or I'm getting smaller. My numbers are getting smaller as I go to the left. So that's going to be negative x. If I'm going up, I'm on my y-axis and I'm headed toward the positive direction. And if I'm going down, I'm on my y-axis, but I'm headed in the negative direction. So that's our key for different phrases that we'll see to know what we would actually be doing with the algebra. We're going to write down 4 different examples, and I want you to write these out so that you have them in your notes. But of phrases that you'll see for the translation, and we're going to write the algebra for them underneath. So leave enough space. But the first one would be 3 to the left, 1 down. 3 to the left and 1 down. Now, like I always do, I circle the ones that are going left and right, and if they're going up or down, I usually do a different kind of underline, so I'll do 1 down. And that way I kind of know when I'm writing out my algebra which one is x and which one is y. So I'm going to write out my x and my y, and I'm going to do them in parentheses. I'll write my phrase for x right here and for y right here, just like I would if I was writing a coordinate pair. So if I'm going 3 to the left, here's my left right here. That's taking away from x. So I'm going to write x minus, and I'm going to the left by 3, so I'm subtracting 3. So it's going to be x minus 3. And if I'm going 1 down, down is also taking away from y. So I'm going to be y minus, and I'm going down by 1. So y minus 1. So if I'm translating 3 to the left and 1 down, that means I'm taking 3 away from x and 1 away from y. Alright, so let's do our second example. 1 to the right and 4 up. 1 to the right and 4 up. Okay, so I'm going to circle the 1, and that's going to the right, and then I'm going to squiggle the 4, and that's going up. And now I'm going to draw my parentheses for my expression. So I need my x and my y. My x will go here, and my y will go right here. So 1 to the right, that's talking about my x, and if I'm going to the right, I'm getting positive. So I'm going positive by 1. So my x is x plus 1. Now for my y, if I'm going 4 up, that means that I'm going up, so I'm going positively on y. So y is positive, and I'm going up by 4, so y plus 4. Alright, 2 more. 2 to the left, 2 up, and 7 to the right, 3 up. If you want to try those for a minute first before I go over them, you can. I have my 2 to the left, 7 to the right, and then 2 up and 3 up. So I'm going to write my parentheses. My x will go here, my y will go here. And I made that a little bit too big. My x will go here, and my y will go there. So 2 to the left, let's start with this one. If I'm going to the left, I'm going negative on x, so x minus, and I'm going negative by 2, so x minus 2. And if I'm going 2 up, then I'm going positive on y, so y plus, I'm going positive by 2. Okay, and then last one. If I'm going to the right, I'm on x, and I'm on positive, so x plus, and I'm going positive by 7, so x plus 7. And then if I'm going 3 up, up is a positive y, so I'm adding to y, and it's going up by 3, so I'm adding 3. Okay, let's move on to our reflection section. If I have a reflection, I'm told whether I'm reflecting over the x or y axis. That's the only thing I'm told. So let's think about this triangle reflecting over the x-axis. I always shade what axis it's going over, so it's going over the blue. So imagine you're in track and you're doing the high jump. You're going over the pole, so it's going to go over blue and end up over here. And at each point it has to be the same distance away from the axis as it was before. So this one would be all the way down here. My reflection over x would look like this. If I was reflecting over y, that means it would be coming this way. So over y is this way, over x is that way. So if I'm going over y, then this point go on the same distance over here. This point needs to be the same distance over here, and this point. And it's rough, but it would look a little something like this if I reflected over the y. So that's just my quick review of reflections, but we figured out the shortcut for how to figure out where something's being reflected. So for your notes, when something's reflected over the x, when it's reflected over the x, the y's change sign. When something's reflected over the x, the y's change sign. And then we discovered one other thing. When we reflected over the y-axis, the x's changed sign. So when we were reflecting over the x's stayed the same, but the y's would go from positive to negative, or negative to positive. When we reflected over the y, the y's stayed the same, but the x's would change from positive to negative, or negative to positive. So let's do 3 examples. Here's the first example. Example 1. Okay, triangle A, B, C reflected over x, reflected over the x-axis, and here are your coordinate pairs, 3, 2, -1, 4, 3, -3. Okay, when I'm reflected over the x, remember the x's will stay the same, but the opposite, the y, will change sign. So I'm going to search, so this is my x, my y, x, y, x, y. So this is the one that's going to change. So I'm going to rewrite my ordered pairs underneath, and x is going to stay the same, but y, this one is going to go from 2 to -2. My x stays the same. My y is going to go from 4 to -4. My x stays the same. And my y is going to go from being -3 to +3. It changes its sign. So I went from having 3, 2, -1, 4, 3, -3, to 3, -2, -1, -4, 3, 3. Example 2. Triangle LMN reflected over the y-axis. And here are the coordinate pairs. -1, -2, 3, 4, -10, 12. So this is reflected over the y-axis, which means the y's are going to stay the same. The x's are going to change sign. So, if I rewrote my ordered pairs, this one would stay the same, this one would stay the same, this one would stay the same, but the x's will change sign. So the -1 will become +1, 3 will become -3, and -10 will become +10. And for your example 3, I want you to make up your own reflection, and I want you to call your triangle A, B, D. But you can have it reflect over either one, and you can have any sets of coordinates for A, B, and D, but I want you to reflect it and have the correct ones written underneath it. We spent a lot of time on rotations. So for rotations, I'm just going to do kind of 2 things that we need to review. One is that the rotations that we're doing will always go around the origin. They will always go around the origin. That means that this center point right here, the origin, if I'm rotating a triangle, it will go around so that it's always the same distance away from this center point. So I'm always reflecting around the origin, rotating around the origin. And then the second thing is we just need to write down what quadrant goes where on a coordinate plane. Because there's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So the way that I always remember it is I draw an x and y axis, and then I write a C for coordinate plane. And in the direction that you write a C, you label each quadrant starting with the number 1. So I started my C right here, so this is quadrant 1. And then I moved right here, this is quadrant 2. And then I was right here, this is quadrant 3. Then I finally got to this one to end my C, so this is quadrant 4. That's how